We're going to take a look at integration of e of x and a to the x. So go ahead and make a tab and label it e to the x and a to the x. Alright, so the integral of e to the x. Well, remember from derivatives, the derivative of e to the x remains e to the x. And if integration is derivative backwards, then the integration of e to the x is also still e to the x. Listening check, color in the title, the integral of e to the x. So the integral of e to the x dx is e to the x plus c. And if you had a number there, so like e to the 2x dx, it'll be e to the 2x over 2 plus c. Alright, so let's take a look at an example. Let's say we have this function listening check, circle example 1. Just like before, you let u equal the exponent, so 3x squared plus 1. Take the derivative of that, that's 6x dx. I don't have 6x dx, I have x dx, so I just divide by 6 to both sides. That will give me du over 6 is x dx, which I can now substitute by using my u substitution. So the integral of e to the u, and then dx is going to be replaced by du over 6, so 1/6 on the outside. Then take the integral of that. Well, the integral of e to the u is still e to the u, so you have the same thing without the integral. And then return what u is, so e to the 3x squared plus 1 over 6 plus c. And that's pretty much it. So this one's actually really, really simple. Let's take a look at one more example. Let's say we had cosine x e sine x plus 1 dx. So same thing, let u equal sine x plus 1, the exponent. Take the derivative, which is going to give me the derivative of sine is cosine dx, which is replacing the whole thing, so I don't need to change anything. So that's going to be the integral of e to the u, and then du is cosine x dx, so that's just du. So the integral of e to the u is e to the u. Put u back in and plus c. Alright, so that's pretty much it, pretty straightforward. Also, a to the x is very straightforward. Remember, we did this before in differentiation. Y is equal to a to the x, right? You take log of both sides, then you bring the x down using the power rule for log, and then you raise it back up to e to the whatever to get rid of the log on the y. So y to the ax can be rewritten as y equals e to the x log of a. So listening check, color this entire sentence we're writing right now, where log of a, remember, is just a constant. It's a number. Don't forget, it's not a variable, it's just a number. Once you have that, you just take the derivatives of e, which is easy. So let's take a look at an example in general terms. Let's say we have this. So we need to rewrite it in terms of e, because we know how to take the integral of that. This is a listening check, box example 1. Right, let u equal the exponent. Take the derivative. Well, remember, log a is just a number. So if I had u equals 2x, the derivative of that would be 2, right? So because log a is just a number, the derivative of x log a is log a. The x goes away, dx. Alright, so go ahead and replace it. So you're going to get the integral of e to the u, and then dx is replaced by that, which means I need to divide by log a, because there's a log a in my answer. So I get du over log a is equal to dx, and I can replace dx with du over log a. So 1 over log a du. Take the integral, is the same exact thing, so e to the u over log a. This is a listening check, color in log a is a constant, plus c. Now replace x back in there. And now remember, e to the x log a, it can be rewritten as a to the x. So the final answer is a to the x over natural log a plus c. Alright, let's take a look at another example. Let's say we had 5 to the x dx. So again, y equals 5 to the x, takes log of both sides, bring the power down, and then raise it back up, get rid of the log. So we can rewrite that as e to the x log 5. Let u equal the exponent, take the derivative, which would just be log 5, because that's a number, dx, and then du over log 5 is equal to dx. So now we're going to write it, replacing it, so e to the u. The listening check, circle example 2, and dx is replaced by 1 over log 5 du. Take the integral, it's still e to the u over log 5 plus c, return x, so e to the x log 5 plus c, and then remember that can be rewritten as 5 to the x over log 5 plus c. And that's pretty much it. So if you remember from derivatives, there was a shortcut, and there is a shortcut. I'm just going to do it the shortcut way and then show you that it's still the correct answer. So let's say we had 2 raised to the 3x dx. The shortcut says that it's going to be 2 to the same thing over log of 2 times the derivative of the exponent, which in this case is 3. And we can raise that 3 up by using our log identities, I suppose. So it'll be 2 to the 3, which would be log of 8 plus c. So this is really our shortcut answer, but I'm going to show you how we can do it the long way and still get the same thing. So y equals 2 to the 3x. Take natural log of both sides. Bring the 3x down, and then get rid of the log by taking exponents of both sides. Now replace that as the question. Let u equal the exponent. Take the derivative. So in this case, it's the constants of 3 and log 2. 3 log 2. And we can use the log, I guess, identities to raise that up. So it'll be log of 8 dx. And then there isn't a log of 8, so I'm going to divide by log of ln 8. And that's going to give me du over ln 8 is dx. So now we substitute. So it's going to be e to the u. And then outside is going to be 1 over ln 8 du. Take the integral, it still remains e to the u, so we're going to have e to the u ln 8 plus c, and then return the u, so that's going to be e to the 3x log of 2 over ln of 8 plus c, and remember that's equal to the original, which was 2 to the 3x over ln 8 plus c. And you can see that both of those answers are the same thing. So if you remember the shortcut, it just saves you a lot of time. And that's pretty much how you integrate those things. So let's practice.